All right. So the first one says, given the equation y equals 1/2 x plus 3, I'm expecting A to be wrong by most of you. Just saying. And I would star A, and I hope you're not wrong. That would be super awesome if you're not. But it's the number one where people make mistakes, especially because we're just kind of getting into putting them all together. So determine the equation of the function with a reflection in the x-axis. So what some people do is they just immediately go and put the -1 in front. But we need to remember that we need to do replacement notation. So I'm going to take my y and I'm going to replace it with -y. If we use replacement notation, we'll actually remember to distribute it to the whole equation, which you might have done, and that's perfect too if you didn't do it with replacement. So we go -y equals 1/2 x plus 3. Now we want to get rid of that -1, so we're going to divide by -1 each term. So we get y equals 1/2 x minus 3. So the -1 has to go to both. If you put the -1 in front and didn't do replacement notation, not a problem. There's a negative. Forgot to put it there. If you just distribute the negative in and don't do replacement, you might have went like this. Y equals -1/2 x plus 3. If you did this, you're going to be wrong every time. If you do this, remembering that it has to go to both, you would have got the same answer as I did. So either way, we'll get the same answer. But if you use replacement each time, you'll always get the right answer. So if you start it with the y first, then move it over and use replacement, you'll always get the right answer because you'll distribute it through. Okay? Now, you should have known that you were wrong if you didn't have the right answer for this one. Because does this equation have an f in it? Nope. So what could you have done with it? Graphed it. You could have put it into y1 and y2 and seen if it actually reflected on the x-axis. And then you would have caught your mistake. At least you would have known you were wrong. You maybe wouldn't have known how to correct it, but you would have known you were wrong. But also that way you maybe would have seen where you would have needed to correct it. Now if the reflection is only on the x-axis, where are my invariant points then? Remember with reflections? Your invariant points are on the actual mirror, right? So if there's just a reflection, your invariant point, your point that doesn't change, should remain on that x-axis. Because it should reflect above, it should reflect below, but what's on that x-axis should stay the same. So another thing, if I would have typed into y1 and y2, invariant points should have been on the x-axis, and if they weren't, I made a mistake. Okay? So please remember, if there is no f in the equation, you can type them in. Check them out. This one, I assume most people got correct. So it's a reflection in the y-axis, so my x is going to get replaced with -x. So I just get y equals 1/2 -x plus 3. The negative can join the 1/2, so I get -1/2 x plus 3. And in this case, because there's a reflection in only the y-axis, I should have invariant points on the y-axis, right? All the negative x's should be becoming positive x, and all the positive x's should become negative x, but the y-axis will stay the same. Yeah?
Is it incorrect to write it how you have it above the answer?
It's not incorrect, it just won't be a multiple choice answer. And if it was a numeric response answer, it would be like -ax plus b, and then you'd have to have them together. But if you left it like that on a written response, it'd be just fine. Yeah. So for 2, we need to get them into y equals form. So we go y equals f -x minus 5. It says describe in order the transformations represented. So in order, that means you have to go stretches first, reflections next, translations, SRT, CERT. It has to be in that order. So on the unit test, if you don't put it in that order, I cannot give you marks, okay? They won't on the diploma either. Stretch, reflect, translate, CERT, okay? Now, there are no stretches because there's no numbers in front. There's a reflection because there's a -1 in front of the x. So I have a reflection in the opposite axis, because if it's making all my x's negative, my negative x's are becoming positive, my positive x's are becoming negative, and I have a reflection in the y-axis. And then I have a vertical translation, space too short for me, vertical translation, five down. If you put down 5, that's fine too. Same thing. Because this isn't with the x, it's not in the bracket, right? So it's 5 down. B, star, 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 star. People usually mess this one up too. I told you, and you probably messed up because you haven't done transformation since last week, so that might be why as well. But I told you that your horizontal translation, the only way it works is if you have a positive 1 in front. So if I had given you like y equals f3 x plus 7 minus 2, I have a plus 1 in front of my x. I move 7 to the left. I'm golden, right? And I'm always going to get my horizontal translations wrong if I don't check if I have a positive 1 in front. So let's look at this one. People will say 3 to the left. It's actually not 3 to the left. I can't even say what it is right now because there's not a positive 1 in front of that x. So I have to remember to take the GCF of negative 1 out. So I'm going to get y equals negative f bracket, take the negative 1 out of these two terms. So GCF it out. So negative x divided by negative 1 is 1x. So there's my positive x. Positive 3 divided by negative 1 is negative 3. Close bracket minus 2. So some people think this isn't with the x anymore. It 100% is with the x. How do I know it's with the x? If I distributed it back in, would it be with the x? Yep, so it's still with the x. That's why I put that extra set of brackets around it. So if you forget to take the negative 1 out, if you forget to look for that positive 1 in front of the x, your horizontal translations will be wrong every single time if there's not a plus 1 in front already for you. So you have to look for the GCFs on your unit tests. You have to look if there's a negative 1 or a number in front, it has to come out. So once I've done that, then I can do my transformations. There's no stretches because there's no number in front of the f and there's no number in front of the x. There's a reflection in both and you can put them together. So you can say a reflection, reflection in the x and y axis. You can write them separate too, it doesn't matter. And I do my translations. I have a vertical translation, 2 down. And a horizontal translation, 3 right. So if you've noticed, if you forgot to take that negative 1 out, it's not going to affect your reflections. It won't affect your stretches. The only thing that's going to be wrong is your horizontal translation. And they'll have the answer to the wrong one there. So you won't even catch you made an oopsie. You have to remember, I need to have a plus 1 in front of my x before I can state transformations or mapping. I need a plus 1 in front. Okay? This one says the key point 110 is on the graph of y equals f of x. So it's on the original, because they can give us the image point and ask for the original, where we have to undo what we did. This, they gave us the original, and they're asking for a new point. If we're moving a coordinate, what do we use? Mapping, every single time, right? So it says determine the coordinate of its image point under the following transformation. So I'm going to move that 4 over first. Y equals f, x minus 5 minus 4. I have a plus 1 in front of my x. That's the next thing I check for every single time. I have to have a plus 1 in front. If I don't, I have to GCF. That should be my, get it to y equals and a plus 1 in front of my x. Then I can do stuff. Okay? So I'm going to horizontally translate 5 to the right. Mapping and words are the same thing. So I need to move my x 5 to the right. I do x and I add 5. That's how I get it 5 to the right. I need to vertically translate 4 down. I'm going to start at y and subtract 4. Then I do 110. Becomes 1 plus 5, 10 minus 4, and it becomes 6, 6. So my image point, my new coordinate is 6, 6. This one's already in y equals. and I have a 1 in front of my x. So I'm in a good form to start mapping. So xy becomes, this is not with my x, so it's going to affect my y. So I'm going to go minus y. And then I need to move 12 to the left, so I'm going to subtract 12. Then I plug in my point. 110 becomes 1 minus 12, negative 10. So it becomes negative 11, negative 10. What's up with c? It's in y equals, but I don't have a 1 in front of the x. So I have to do that, right? First two steps, get in y equals, get a 1, positive 1 in front of my x. So I'm going to get y equals f, bracket, take the negative 1 out, and then I get x minus 3. So I have xy becomes negative x plus 3y. This is why I'm not as worried about daily quizzes. I'm worried about you learning from the daily quizzes, not the marks from your daily quiz, right? So I know these have probably been mistakes. You haven't seen it since last week, right? But you'll remember it if you make a mistake too. So if we go 110, you can get negative 1 plus 3, comma 10, which gets you 210. And remember with your mapping, you need to have XY, arrow, new point, correct? If you just have new point, you are not doing mapping, they will give you no marks. That's not mapping. Mapping is, my original point was XY, it becomes with an arrow, new coordinate. Okay? Has to be in that format. This one, I'm moving points. I'm moving coordinates. If I move a coordinate, I use mapping. If I move more than one coordinate, I use mapping. And I'm still just moving coordinates, right? A graph is just a whole bunch of coordinates. So I need to get into y equals g negative x plus 1. Now some people will say, well, it doesn't have a positive 1 in front of the x. In this case, does it matter? No, because I don't have a horizontal translation. You just need to have that positive 1 if you have a horizontal translation. I could write it as negative 1 bracket x. It would be the same thing. So my mapping is going to be xy becomes negative x, and then I need to move my y up 1. So I'll use my negative 6, 3 first. Negative 6, 3 becomes negative and negative 6, comma 3 plus 1. So it becomes 6 and 4. And I'm going to plot that. And I go to my next one because I want to go in order. Negative 4, negative 3. So you become negative and negative 4, comma negative 3 plus 1, which is 4, negative 2. I plot that, connect. So I don't connect them weird and wrong. Go to the next point, 0, 0. It becomes negative 0, comma 0 plus 1. So I get 0 and 1. Connect. And then I have 4, negative 4 becomes negative 4, comma negative 4 plus 1, which is negative 4 and negative 3. This point stayed the same. Is it invariant? Trick question. Did that point actually stay the same? No, that was this point. It just happened to land on a point from another graph, right? So it's not invariant. Invariant is, I had a point, I did all this stuff to it, I still have that same point. That's invariant. Okay? Make sense? Perfect. Okay, I'm going to get you to your math because I'm going to hand out a little handout. Easy. So what I need from you is I need you, if I give you an equation, or I give you mapping, or I give you replacement notation, or I give you words, that you can give me the other 3. If we can do that in our sleep, no problem. I never make a mistake. This unit test will be a cakewalk. It's this part that people don't get solid, and then I start asking you domains and ranges and x-intercept movement, and then it's just a mess. Because you mix up flipping them or not flipping them. or saying it's about the wrong axis and stuff like that. You just mess up the numbers. So the first one we'll start with is I'm going to give you an equation. So it's 3y plus 6 equals f of 2x. Now what you need to know is equation and replacement notation, friends. Words and mapping, besties. They're the exact same. Why do I say that equation and replacement are friends? Because if you have it in y equals, they're not besties. But if you have all the y's on the right-hand side, left-hand side, and you have all the x's on the right-hand side, you have replacement notation. Because replacement notation is, I give you an original equation like y equals f of x. Replacement notation is x gets replaced with something, and y gets replaced with something. That's what replacement notation is. I go in, I take the x, I toss it behind my head, and I completely replace it with this. Or I go in with the y, I toss it behind my head, and I completely replace it with this. Okay? So if you have all the y's on the left, you have your replacement. So I start out with an easy one. All my y's are on the left. So if I took this y up here, this one right here, I tossed it out, I would completely replace it with 3y plus 6. That's replacement notation. So my y is going to be replaced with 3y plus 6. Then here I take my x, I toss it behind my head, and I'm going to completely replace it with 2x. That's replacement notation. So if your y's are all on the left and your x's are all on the right, your replacement notation is easy. Okay? The equation is only, the replacement notation is easy from here. But if I want to talk about words or mapping, I want to get it into y equals. Okay? So the first thing I'm going to do for this one is I'm going to subtract 6. So I'm going to get, I'm going to need space over here because I'm out of space. So I'm going to get 3y equals f of 2x minus 6. And then what am I going to do? Yeah.
You can take the 3 from the left side and multiply that.
Divide.
But you can multiply it by 1/3.
You can multiply it by 1/3, or we're going to divide each term by 3. So you're going to multiply the f by 1/3, but we have to remember to also do it to that back term, and that's just going to burn people. You have to do it to the translation as well back here. So I'm going to have to divide this by 3, divide this by 3, because f of x is one term, right? F of 2x is still one term. But I have to also remember to divide the 6 by 3. And that's where people error. So we're going to get y equals, this is totally true, we're going to multiply this by 1/3 because it's nicer. 1/3 f of 2x, and then subtract 2. And now I actually have it in y equals format, which is helpful for words and mapping, because words and mapping are the exact same thing, just a different way of explaining. It's like if you came up to me and you were like, I don't understand words, I could teach you mapping, and it would just be another way of explaining the same thing. So whatever numbers we use in words, we're going to use that exact same number in mapping. So if I used a 2 for vertical stretch in words, I'm going to multiply my y by 2. If I used a half for my horizontal stretch, I'm going to multiply my x by a half. So your words and mapping numbers never change. If they're changing, you're oopsing. Okay? So let's do our words first. So I have a vertical stretch and a horizontal stretch because I have numbers in front. So I'm going to say a vertical stretch, really tiny, by a factor of, and it has to be written just like this. You can't do it in your own form. Vertical stretch by a factor of what? If we have it in y equals, do we flip or change any of the y's? No, they're accurate, right? So whatever my y's are accurate if I have it in y equals. My x's are the flippy stuff. So 1/3, it's vertical, so it's about the x-axis. Then I have a horizontal stretch. If it's with the variable, it flips. Is x always with the variable? Yep. So it always flips. Are my y's with the variable currently? No, so they don't flip. So I have a horizontal stretch by a factor of, it always flips. By a factor of, it's 2 over 1 currently, so it's going to be a half. About the x-axis. Y-axis. Not it. So it's about the opposite one. And then all I have left is this minus 2 at the back. So it's the vertical translation 2 down. Now I can go to my mapping. What numbers do I have? A third, a half, and 2. What's going to appear in my mapping? A third, a half, 2. They're not going to flip. They're not going to change. They could have sign changes, but that's it. So I have x, y. My stretches always multiply. So this is a vertical stretch, a third. So my y is going to multiply by a third. So horizontal stretch by half. My x is going to multiply by a half. Do I have any reflections? No. If I did, I'd multiply by negative 1s. But I don't. All I have left is a vertical translation 2 down. So I have minus 2 from my y. So what numbers I have in words are the same numbers I have in mapping. Same thing. Okay? If you're flipping them, you have a problem. So I'm going to give you one to try where I give you the equation and you try it. This one, again, I just gave you like a repeat with a little bit of a tweak, just so it wasn't exactly the same as the previous one. But it's still, all my y's are on my left, all my x's are on my right, correct? So my replacement notation, I have, like that. So my x is going to be negative x plus 3. My y is going to be 2y plus 6. So those are fast if I have them y's on left, x on right. Yeah.
Would that also be correct then to have like a negative 2y minus 6 and then negative, or then the opposites with x as well? Like if, say, the x was on the left side and the y was on the right side?
You will always have your x's attached to your f. So if you fully just swap the whole thing, it would be the same thing. Because you could just fully swap them back. Like if I just, you know what I mean?
Yeah.
And your x will always be over here. The problem is that your y might be partially over there. And then you'll just move it back to the left.
Okay.
For replacement notation. So if I want to do this part though, I need to get my y by itself. So I'm going to subtract my 6 over. I'm going to use 2 lines at a time because I don't care. I have lots. So I'm going to go 2y equals f negative x plus 3 minus 6. And then I'm going to divide by 2. I should be using a different color. Y equals a half f negative x plus 3 minus 3. And then people will say I'm good to go with stating all my words and stating all my mapping. What was my thing? I need to get into y equals. I have 2 things. I need to get into y equals and I need to have a 1. Plus 1 in front of my x. Do I? No. So could I have done that in 1 step? Sure. I'm going to do it in 2 now. So y equals 1 half f negative 1 x minus 3. Because when I take a negative 1 out, it just causes it to turn. Now I have it in format that I can do mapping and words. So I'm going to say I have a vertical stretch. I don't have a horizontal one because this is a 1, right? So I have a vertical stretch, and if it's on this side, it's the exact same number. It doesn't switch. So I have a vertical stretch by a factor of 1/2 about the x-axis, because it's always about the opposite. I have a negative with my x, so I have a reflection in the y. Always the opposite. And I have to go stretches, reflections, translations. I have to go in that order. So reflection in the y-axis. I have a vertical translation, 3 down. And a horizontal translation, 3 right. And then my mapping, my x, y, will become stretches multiply, reflections multiply, translations add, subtract. So vertical stretch by a half, my y is going to become a half y. Reflection in the y means I'm going to end up with a negative x. Vertical translation 3 down, subtract 3. Horizontal translation 3 right, add 3. Good. Okay? So both these examples that I gave you were all of the y on the left, all of the x on the right. What do you think I'm going to do next? Not have what? Not have all of them on the same side. Put some of those y's on the other side, which is helpful for words and mapping, but you're going to have to move them for replacement. Okay? So here's my next example. Try this one. Y plus 4 equals f 1/2 x plus 2. I just put it all on one side. And I'll put a 3 in the front. Okay, if I want to do replacement, if that's what they're asking for me, yep, I have to move everything for the y's to the left, everything for the x's to the right. Currently, I have a 3 over here, so I'm going to divide by 3. So instead of dividing by 3, I can go 1/3 in front, and I can leave it with brackets, guys. It's totally fine. You can either distribute it through and go 1/3 y plus 4/3, or you can just leave it like that. Because I have everything on the left, I can do replacement. Everything on the right, I can do replacement. Oh, sweet. Thank you. So I can go y gets replaced with that. X gets replaced with that. So x gets replaced with 1/2 x plus 2. Y gets replaced with 1/3 y plus 4. Or if you're someone who distributed it, you could have said y, this is an or, 1/3 y plus 4/3. Either of those would be appropriate replacements, because I could distribute the 1/3 in. And 4 times 1/3 is 4/3. Okay? That's a perfect form for replacement, but it's not the perfect form for anything else. So I'm going to take this blue, and I'm going to get it into y equals. I'm going to ignore the red that's on there. I'm just going to subtract the 4 over. So I'm going to get y equals 3f something minus 4. Because I want to get it into y equals. So why would I go doctor this one when I can just go back up to the nice one up here and just move the 4 over? Right? Now, why did I leave that bracket open like that? Because there's no 1 in front. Everyone's going like this. That's true. There's no 1 in front. This is where people err when the GCF is a fraction. So if you're someone when we go through this, if you're someone who did the error, I would start this one again. So we take a half out, and we're going to get x plus 4, not 1. Why the heck is that? Because when you divide by a fraction, you actually multiply by the reciprocal. So we're technically, when we're taking that half out of the 2, we're going 2 divided by a half, aren't we? Which is the same as 2 times 2 over 1, which is actually 4. So if you're someone who knows you're going to make that error, you can just use your calculator and you can go 2 divided by bracket a half, and it'll tell you it's 4. Your calculator will literally tell you that. Just remember that when you divide by a fraction, it's like multiplying by its reciprocal. So when you divide, when you take a GCF of a half out, you're actually taking 2 and dividing it by half, which is the same as 2 multiplied by 2. It gets bigger, not smaller. And they'll have the error to you taking the half out and giving them x plus 1. But remember, if I take a 2 out, I should get 1. Now this is how you can tell if you screwed up. When you take a GCF out, you can put it back in and see if you get the same thing, can't you? So if I took the half out, I can put it back in and see. I better get the same thing back. So a half times x is a half x. A half times 4, 4 times a half is 2. I didn't make an oopsie. If I had this instead, a half x plus 1, if I distributed that back in, I'd get a half x plus a half. Was that what it was? No, so you know you made a mistake. So GCFs can always be checked, because when you take a GCF out, you can put it back in and see if you get the same thing. If you don't, you oopsie, right? You can always double check. Okay. So, words. I have a vertical stretch, I have a horizontal stretch, I have a horizontal translation, and I have a vertical translation. Neither of these are negative, so I don't have reflections. I have to do stretches first. So I have a vertical stretch. By a factor of 3, because it's not with the y, about the x-axis. It's always about the x when it's vertical. I have a horizontal stretch. By a factor of 2, because it always flips from equation to words. About the y-axis. I have a vertical translation. Four down. It's always right. And then 4 left. Horizontal translation. And then mapping and words are the same. So x, y becomes, if I'm vertically stretching by 3, my y is being multiplied by 3. If I'm horizontally stretching by 2, my x is being multiplied by 2. I have no reflections, so they're staying positive. Vertical translation 4 down, I'm going to subtract 4. Horizontal translation 4 left, I'm going to subtract 4. You're literally just representing the same thing in a different way. Right? Okay. I'm going to give you words. You're going to give me equation, mapping, and replacement notation. And remembering your original equation is just y equals f of x. I have it up here. So you're just changing that. Go 8. Vertical stretch by a factor of 8 about the x-axis. Reflection in the y-axis. Horizontal translation. To right. Okay, words and mapping are the same, so I'm going to go with them first. Because if I'm getting words, I'm doing mapping if I have a choice. Because they're the same. So my x, y will become vertical stretch. So I'm multiplying my y by a factor of 8. I'm going to get 8y. I have a reflection in the y-axis that affects my x. Reflections affect them by multiplying by -1. So a reflection in my y-axis, I'm getting a negative x, or a negative 1x, same thing. Then I have a horizontal translation to right. I'm going to add 2. Want to know what's great about replacement and mapping? They're flips of each other. I'm going to erase this pencil too. Replacement is just mapping with brackets and flips. That's all it is. Because you're replacing x with x and y with y. And when it's with the x, it flips, right? When it's with the y's, it flips. So, this is what I do. If I have mapping, I have replacement. Very easy. My x will become that x with everything flipped in brackets. So, whatever's in front, -1 is going to be in its own bracket. I'm going to get my x, and my +2 is going to become a -2. My y, I'm supposed to be multiplying by 8y. I'm actually going to multiply by 1/8 y. Do I really need to put the bracket like that? No, I'm just proving the point. So your reciprocal or your replacement notation is just that with brackets and flip. Everything flips because the y's are actually with y now, not on the other side, right? So we're going to get 1/8 y equals f of -1 x minus 2. What's great about this? If I get this into y equals, I can check and see if I actually got what I was supposed to get, right? So I can multiply by 8. I can leave it like this. It's totally fine. Or I can multiply by 8. I multiply this side by 8 and this side by 8. This is one whole term, right? Because it's f of x. That's all that is. So I'm going to get y equals 8 f -1 x minus 2. And then I check it. Vertical stretch by factor of 8. Boom. Reflection in the y. Boom. Horizontal translate to right. Yeah. So you should be able to back check everything as long as you know it all. Like I said, the catch here is that it's flipped. I'm just going to give you a mapping and then one of these just to show you. Just this part, and then I'm going to give you homework. And then we're going to keep doing this tomorrow, so don't lose the sheet. We're going to practice more tomorrow. So if I give you xy becomes 1/2 x plus 3 bracket -2y plus 6. I'm making it hardcore. So say that's my mapping. What I want to drill home is how to do your replacement. Mapping to replacement is really easy. You add brackets and everything flips. So I have xy equals 1/2 x. So what is this? This is a horizontal stretch by a factor of 1/2 about the y-axis, or horizontal translation, 3 left. Vertical stretch by a factor of 2 about the y-axis, about the x-axis. A reflection in the x-axis, 6 down, up, not down. See, this is the problem. Up, down, right, left. What's flipping? What's going? So we have to have it so that it is literally part of our being. Replacement notation. X becomes, make myself an extra bracket. The half turns to a 2, and I get an extra bracket, and then it's going to be, instead of x plus 3, it's x minus 3. Brackets. So when I do replacement from mapping, it's literally mapping flipped with an extra bracket. So I flip the half to a 2, I put an extra bracket in, x plus 3 turned to an x minus 3. If you memorize that, your life is gold. Y, I have -2, I'm going to make it be -1/2. Bracket, y plus 6, y minus 6. If you go from mapping to replacement notation, it's really easy. You flip everything and add an extra bracket. That's it. Okay? Your homework isn't like this. We're going to go through more of this. Do you see why I'm doing this, though? So that you're not, like, accidentally flipping +6 down, up, right, left, I don't know. Okay? If we always just keep practicing these, then we have it as we've learned it, instead of trying to memorize and then we flip them. Your homework is basically on combined transformations. It's a shorter one. It has quite a few parts, though, so it's not that short. It's page 38, numbers 3, 5 to 9. So this is one where they'll give you like the equation and ask for the transformation, something basic like that. Okay? Tomorrow, we're going to go through more of these. We're going to have a quiz. We're going to go through more of these. Then we're going to go through how do we make an equation from a graph. And then we're going to go through, if I give it, how does the domain change? How does the range change? All that. So we're going to finish up transformations tomorrow, all the different transformations. And then on Thursday we do inverses, which is the last lesson in transformations. Finish that on Friday. And on Monday we start polynomials. So we don't have a unit test on this. I'm putting the two units together. So we have more practice with transformations. So that's your homework.